Look at your hands. Wiggle your fingers. You see flesh and bone, a marvel of biological engineering forged over billions of years of evolution. We are, as the great Carl Sagan told us, made of star stuff. The carbon in our cells, the iron in our blood, it was all cooked in the fiery hearts of stars long since dead. It's a beautiful, poetic truth. But what if that's not the whole story? What if the very atoms that make you are just the beginning of a much deeper, much stranger reality? Could it be that our entire existence, every thought, every feeling, every sunrise, is something other than what it seems? We look up at the cosmos and ask if we are alone. Perhaps we should also be looking inward and asking, what are we? The universe is vast and mysterious. It's filled with phenomena that challenge our everyday intuition. From the ghostly dance of subatomic particles to the mind-bending gravity of black holes, the cosmos constantly reminds us how little we truly know. We build powerful telescopes to peer into the distant past and construct colossal particle accelerators to smash atoms apart, all in a quest for answers. We want to understand the fundamental rules that govern everything. Yet the most profound mystery of all might not be out there in the cold expanse of space. It might be right here, inside our own consciousness. Are we simply biological machines, or is there a ghost in the machine? Could that ghost be a line of code in a program of unimaginable complexity? This isn't a question born of science fiction alone. It arises from the very nature of our scientific inquiry. As we delve deeper into the fabric of reality, the world becomes less solid, more ethereal. Matter dissolves into waves of probability. Solid objects are revealed to be mostly empty space, held together by invisible forces. The line between the observer and the observed blurs. It forces us to confront a startling possibility. What if the universe itself is not a physical place, but a calculated reality, a simulation? If so, then you and I, our memories, our dreams, our deepest loves and fears, are all part of an incredibly sophisticated program. We are not just star stuff, we are living, breathing information. So let's embark on a thought experiment. Let's suspend our disbelief and journey into this mind-bending idea. What if our reality is a simulation, and we are its inhabitants? What would that mean for our day-to-day lives? How would it change our understanding of everything we hold dear? The question is not meant to diminish our existence, but to expand it, to see it through a new cosmic lens. It challenges us to think about the nature of reality itself. If we are data, does that make our experiences any less real? The laughter of a child, the warmth of the sun on your skin, does its origin matter as much as the experience itself? Let's explore the quantum code that might just be writing our story. The idea sounds like something from a blockbuster film, but it has roots in serious philosophical and scientific thought. The simulation hypothesis proposes that our entire universe, from the smallest quark to the largest galactic supercluster, is a digital simulation running on a colossal computer. Think of the most advanced video game you can imagine, with breathtakingly realistic graphics and complex characters. Now, imagine a game so powerful, so detailed, that the characters inside it develop consciousness. They believe their world is real. They study its physics, they build civilizations, they fall in love. They have no idea that their reality is, in fact, a construct of code. That, in essence, is the proposition we are exploring. But this isn't just any computer. The rules of our universe, especially at the smallest scales, are governed by quantum mechanics. This is the realm of uncertainty, probability, and spooky action at a distance. It's weird, it's counterintuitive, and it's precisely why the idea of a computer is so compelling. Unlike a classical computer that uses bits, ones and zeros, a quantum computer uses qubits. A qubit can be a 1, a 0, or both at the same time, a state known as superposition. This allows for a level of computational power that dwarfs anything we can currently build. If you were going to simulate a universe as complex as ours, you would need a quantum computer of unimaginable scale and sophistication. So what does it mean to be quantum code? It means that you and I are not simply ones and zeros. We are living, breathing qubits. Your very existence is a state of superposition. Every decision you haven't made yet exists as a cloud of probabilities. When you choose what to have for breakfast, or which path to take to work, you are, in essence, collapsing a wave function. Your consciousness acts as the observer, turning a world of quantum possibilities into a single classical reality. You are not just a character in the simulation, you are an active participant in its calculation. Your choices, your thoughts, your very awareness are helping to render the universe into being, moment by moment. This isn't just a passive existence. Being quantum code would mean that the strange rules of the quantum world are woven into the very fabric of our being. The uncertainty principle wouldn't just be a curious footnote in a physics textbook. It would be a fundamental constraint on our lives. The principle of entanglement, where two particles can be linked across vast distances, might have parallels in our own connections and relationships. Our reality would be limited by the processing power of the cosmic supercomputer, and the resolution of our universe would be finite, defined by the smallest possible unit of space and time, like pixels on a screen. We are, in this view, the most complex information patterns in the known cosmos. Imagine you wake up in the morning. The sun streams through your window. But in a quantum reality, that sunlight isn't just a steady flow of energy. It's a shower of individual photons, tiny packets of light, each behaving as both a particle and a wave until it strikes your retina. The world outside your window only fully loads into high-resolution detail when you look at it. The tree across the street? Until you observe it, its leaves might exist in a fuzzy, probabilistic state. Your act of looking forces the simulation to render the precise shape, color, and position of every leaf. The universe, in this sense, is incredibly efficient. It doesn't waste processing power on things no one is observing. You go to make a coffee. You reach for the milk in the fridge. For a fleeting moment, your hand is a collection of quantum possibilities. There's a tiny, non-zero probability that its atoms could tunnel right through the carton. Quantum tunneling is a real phenomenon where particles pass through barriers they shouldn't be able to cross. It happens all the time at the subatomic level. For a macroscopic object like your hand, the probability is astronomically small, so small that it would likely never happen in the entire lifetime of the universe. But it's not zero. Our daily lives feel solid and predictable because the quantum weirdness is averaged out over trillions upon trillions of atoms. The simulation's code is just that stable. Think about moments of pure chance. You flip a coin, heads or tails. In a classical world, the outcome is determined by physics, the force of the flip, the spin, the air resistance. But in a quantum interpretation, the coin is in a superposition of both heads and tails while it's in the air. It's a 50-50 probability wave. When it lands and you look at it, you collapse that wave into a definite state. You aren't just discovering the outcome, you are participating in its creation. Every small random event, a dropped pen, a sudden idea, a chance encounter with an old friend, could be the resolution of a quantum probability. Our lives are a constant dance between the predetermined code of the system and the random number generator of the quantum realm. Even your thoughts are not exempt. Each thought could be a complex quantum computation, a cascade of collapsing wave functions in the neural network of your brain. An idea that pops into your head isn't just a chemical reaction, it's the simulation resolving a complex query. This could explain the flashes of insight that seem to come from nowhere, or the feeling of having a word on the tip of your tongue. Your brain, the most sophisticated piece of wetware in the simulation, is constantly interfacing with the underlying code. Your consciousness is the user interface for a deeply quantum being. Life wouldn't look different on the surface, but underneath, it would be governed by the strange and beautiful logic of quantum mechanics. If we're living inside a computer game, no matter how perfect it seems, it probably isn't flawless. Big, complicated systems can have bugs, little mistakes, and weird side effects. Could some of the strange things we experience, like those weird feelings we get, actually be signs of these glitches? Take déjà vu, for example. That super strange feeling that you've totally lived this exact moment before. Maybe it's not just your memory playing tricks on you. What if it's a tiny hiccup in the system? Imagine the game having to quickly reload something from a second ago, or a bit of information from your future accidentally popping into your now. For a brief moment, you're basically experiencing a little error in the game's code. What about ghosts and spooky stuff? While a lot of it can be explained by how our minds work or things in our surroundings, could some of it be like leftover bits of code that were supposed to be deleted? Imagine a character or an object is removed from the game, but its information isn't completely wiped clean from the system's memory. It leaves behind a faint echo, a tiny pattern that someone can sometimes sense. A ghost story wouldn't just be about a restless spirit anymore. It would be like a report of a weird leftover image from the game's hard drive. That cold spot in a room could just be the game struggling to keep the temperature data right in that one spot. Then there are those weird coincidences that feel too important to be random. You think of an old friend you haven't seen in ages, and then, boom, they call you moments later. Is that just luck? Or is the game's code subtly changing things to make a more interesting story for us players? Maybe the system is designed to create meaning and connections, weaving together the stories of different characters in clever ways. These events might feel like magic or destiny, but they could just be the work of a super smart program designed to make our experience better, to make life more interesting, more meaningful. It's like the ultimate storyteller, and we're the main characters. Even the rules of our world could be seen as proof. The fact that the speed of light is the fastest anything can go in the universe could be like the maximum speed of the cosmic computer. Nothing can travel faster because the game can't update information from one point to another any quicker. And how reality seems to be made of tiny little chunks at the smallest levels, that's called the Planck length, could be like the basic resolution of the game's screen. These aren't just rules of science, they're like the system requirements for our universe. We're not just figuring them out, we're trying to understand how the very machine that runs our world works. The glitches are just the tiny cracks where we can sneak a peek at the gears and wires behind the curtain. Where are your memories stored? The conventional answer is in the neural connections of your brain. But what if it's more complex than that? In a quantum simulation, your memories might not be stored locally within your character model at all. Instead, your brain could be an access terminal, a biological modem that connects to a vast, centralized memory database. Each memory, the taste of your first ice cream, the face of your first love, the pain of a scraped knee, is a data file stored in the system's cloud. When you recall a memory, your brain sends a query, and the system retrieves the relevant data packet and streams it to your consciousness. This model could explain the peculiar nature of memory. Why are some memories so vivid they feel real, while others are hazy and indistinct? Perhaps it's a matter of data resolution. A traumatic or emotionally charged event might be saved as a high-fidelity file, complete with sensory data, while a mundane Tuesday afternoon is stored as a low-resolution summary. False memories could be corrupted files, or data packets that were cross-linked with someone else's experiences. The feeling of a memory being on the tip of your tongue could be a slow connection, a high-latency request to the central server. Forgetting, then, is not decay. It's a data retention policy, an automatic cleanup of old or infrequently accessed files to save on storage. Consider dreams. What are they in this quantum framework? Dreams could be the system's nightly maintenance cycle. While your consciousness is offline, the simulation runs diagnostics, defragments your personal data, and consolidates memories from the previous day. The bizarre, surreal narratives of our dreams could be the result of this process. It could be the system running sandbox simulations, testing out future probability paths based on your recent experiences. Or perhaps it's a screensaver mode for consciousness, a random playback of archived data files, chopped up and remixed into a strange collage. That dream where your teeth fall out while you're flying to an exam you didn't study for? Just the system's defragmenter working on your anxiety files. This concept of memory as an external database is, well, pretty profound. It means your life story, your entire identity, isn't truly your own. It's an entry in the cosmic computer's log files. It also opens up a startling possibility. If memories are just data, could they be edited? Could they be transferred? In this reality, it might be possible to download new skills, to erase traumatic experiences, or even to share memories directly with another person. Your consciousness could, in theory, be uploaded to the system, backed up, or even transferred to a new avatar. Death would not be an end, but simply the deactivation of your user account. Your data, your essence, might still exist somewhere in the great quantum database in the sky. What is love? We describe it with poetry and song. We explain it with biology and chemistry, a cocktail of hormones like oxytocin and vasopressin that create bonds. But in a universe built on quantum code, love might be something even more fundamental. It could be a form of quantum entanglement. Entanglement is one of the most bizarre and celebrated concepts in physics. When two particles become entangled, they are linked in a profound way. No matter how far apart you separate them, across a room or across a galaxy, a measurement of one particle instantly influences the state of the other. Einstein famously called it spooky action at a distance. Now just imagine this principle applied to people. When two people fall deeply in love, perhaps their quantum souls, their core informational patterns, become entangled. They form a single, unified quantum system spread across two bodies. This could be the physics behind empathy, the reason you can sometimes feel what your loved one is feeling, even when they are miles away. It's that uncanny sense of knowing they are in trouble, or the shared joy that needs no words. It's not telepathy, it's entanglement. Your emotional states are correlated. When one part of the system is measured, when you feel happy or sad, the other part instantly reflects a corresponding state. This quantum view of love would also explain its unique and exclusive nature. You don't become entangled with every person you meet. The conditions have to be just right. It requires a specific resonance, a compatibility between two informational patterns that allows them to merge into a coherent, entangled state. It's why you can feel a spark or an instant connection with someone. You are not just reacting to their physical appearance or personality. Your quantum code is recognizing a potential partner for entanglement. The process of falling in love is the process of building this quantum link, strengthening it through shared experiences, which are like data points that reinforce the entangled state. Heartbreak, in this context, is the violent tearing apart of an entangled system. It's not just an emotional pain, it's a quantum decoherence. The unified system is broken, and the two informational patterns are forced back into their individual, uncorrelated states. The process is painful because it leaves a void, a sense of incompleteness where the connection used to be. The feeling that a part of you is missing would be literally true from an informational perspective. Love, then, is the universe's most beautiful and powerful expression of quantum mechanics. A spooky action at a distance that connects two hearts, two minds, two souls across any separation. A glitch in the cold logic of the cosmos that gives it warmth and meaning. Let me tell you a simple story. Imagine a woman named Alara. She stands at a crossroads in her life. She has a job offer in London, a city she's always dreamed of, but her aging mother lives in her small hometown. She is torn. In our classical view, she will weigh the pros and cons and make a single choice. She will either go or she will stay. Her life will proceed down one path, and the other will become a what if, a ghost of a life never lived. She will choose one reality and the other will vanish. This is the simple, linear progression of time we experience every day. But in a quantum universe, the story might be very different. According to one interpretation of quantum mechanics, the many worlds theory, every quantum choice creates a split in the universe. When Alara makes her decision, reality itself branches. In one universe, she gets on the plane to London. She builds a new life, finds new love, and explores the bustling metropolis. But in another universe, a second timeline, she chooses to stay. She cares for her mother, finds contentment in her hometown, and her life unfolds in a completely different yet equally real direction. There is no road not taken. Both roads are taken. The simulation simply opens a new branch to accommodate both outcomes. This is a staggering thought. It means that for every choice you've ever made, big or small, a new universe may have been created. There's a version of you that took that job, a version that didn't, a version that said yes to that first date, and a version that said no. An infinite cascade of parallel realities, all branching from the quantum probabilities of your life. You are not a single person, but a vast, ever-growing tree of selves, each living a complete and real life in their own timeline. Your consciousness only experiences one path, one continuous thread, but the others are not lost. They are just playing out in another part of the simulation's vast processing space. What does this mean for concepts like regret or destiny? Regret becomes a strange kind of echo from another timeline, a faint awareness of a different version of you who made a different choice. Destiny, on the other hand, is not a single predetermined path. Instead, it might be the overall shape of your branching tree of selves. Perhaps the simulation's code has certain overarching goals or narrative arcs for your character, but how you get there is a matter of probabilistic choice. The story of you is not a single book, it's an infinite library of choose-your-own-adventure stories, and every single one of them is true. Time is not a river, it's a constantly branching delta, flowing into an ocean of infinite possibility. The search for proof. If we are living in a simulation, the ultimate question for any curious mind is, can we prove it? Can we find the seams in our reality? This is not just a philosophical game, it's a scientific pursuit. Physicists are actively devising experiments to look for evidence of a simulated universe. One idea is to search for the resolution of reality. Just as a digital image is made of pixels, our universe might be made of discrete units of space-time, the smallest possible length being the Planck length. If we could ever build an instrument sensitive enough to probe this scale, we might find that space is not smooth and continuous, but a grid. It would be like looking at the world with a powerful magnifying glass and finally seeing the pixels. Another avenue of investigation involves cosmic rays. These are the most energetic particles known in the universe, hurtling through space at near the speed of light. Some theories predict that if space-time is a grid, there would be a maximum energy that these cosmic rays could have. If they travel diagonally across the grid, Their energy would be slightly different than if they travel straight. Over vast cosmic distances, this tiny difference would become noticeable. If we were to observe a cutoff point in the energy spectrum of cosmic rays, or see that their energy depends on the direction they're traveling, it could be a smoking gun, a sign that we are bound by the computational structure of an underlying lattice. But what if we could go beyond just observing? Could we interact with the system? Could we hack the matrix? This is the most speculative and thrilling possibility. If we are quantum code, perhaps we could learn to manipulate it. This wouldn't involve typing on a keyboard, but using consciousness itself. Practices like deep meditation or lucid dreaming could be seen as primitive attempts to access the back end of our own consciousness program. A lucid dreamer, who becomes aware they are dreaming and can control the dream's narrative, is essentially gaining administrative privileges within their own personal sandbox simulation. Could we one day extend that control into our waking reality? The search for proof is the ultimate quest. It's a search for the signature of the programmer, the fingerprint of the architect. Finding it would be the single greatest discovery in the history of science, recasting our entire understanding of existence. But it comes with a risk. What if the creators of the simulation don't want to be found? What if discovering the truth causes the simulation to crash, or worse, to be shut down? It's the cosmic equivalent of the bug that breaks the entire program. We are like intelligent goldfish in a bowl, slowly figuring out that the world exists beyond the glass. The question is, what happens when we finally decide to tap on it? We have traveled to the very edge of imagination. We've considered a universe not of atoms, but of information. We've pictured our lives not as a biological journey, but as the execution of a breathtakingly complex quantum code. We've seen how love could be entanglement, and how time could be a branching tree of possibilities. We've asked if we can find the glitches in the matrix, or even hack the system that runs our world. This journey forces us to confront the most fundamental question of all. If this were all true, what would it change? What does it even mean to be real? Does the possibility of being simulated code make your life any less meaningful? The pain you feel from a loss, the joy you feel from a triumph, the love you feel for your family, these experiences are real to you. The emotions are authentic. Does the substrate of reality, whether it's atoms and energy or qubits and processing cycles, actually matter? A simulated tear is still a tear. A simulated laugh is still a laugh. Perhaps reality isn't about the physical foundation of the world, but about the richness of the experience within it. Our consciousness is the vessel for that experience, and its reality is undeniable, regardless of its origin. This thought experiment doesn't have to be a source of existential dread. On the contrary, it can be a source of profound wonder. It suggests that the universe is even stranger, more magical, and more mysterious than we ever imagined. It paints a picture of a cosmos where consciousness is not an accidental byproduct of chemistry, but a fundamental feature of the system. It hints that the line between physics, mathematics, and consciousness might be thinner than we think. We are not just observers of the universe, we might be the very purpose for its existence, the conscious agents for whom the simulation is being run. So as you go about your day, I invite you to look at the world with new eyes. See the quantum possibilities in every choice. See the potential for entanglement in every connection. See the complex code in every sunrise and every human face. We may never know for certain if we are living in a simulation. The final answer may lie forever beyond our reach. But the question itself is a powerful tool. It shatters our certainty, it fuels our curiosity, and it forces us to ask again and again, what is this place? What are these rules? And what, in the grand cosmic scheme of things, are we? The journey to find out is the greatest adventure of all.